Okay, trying to get you a feel for priority here. Listen to the priority. We looked at a slope field question. I'd say at most 2 points out of 108 you can get from understanding slope fields. We did the derivative of an integral. That's quite a bit more. Like understanding that often unlocks other things you have to know, but without knowing that, you're probably going to lose at least 10 points. So that one is significantly more important. This one here, if you don't understand the ideas presented in this problem, you are throwing away 30 points.
Ooh.
So
Isn't it fundamental theorem of?
this is the fundamental theorem. Particle moves along the x-axis. We've done lots of those. They give us a velocity. Velocity is a rate. It is the rate at which position changes. They give us a position. They tell us the position at time 1 is 7. They ask us to find the position at time 2. They look at your golden notes and find the most important box on the entire page. Right-hand side, halfway down, with the big arrow.
Why is it not the biggest box?
Because when I made the chart, I kind of had to find a way to group things logically.
Mm-hmm.
And so it was a lot of like hours and hours of pushing and shoving, and it's just where it ended up. So,
Oh, okay.
yeah. Question. They're giving you a rate. They're asking you to find an amount. So you write down the fundamental theorem. You say, if I integrate the rate, velocity, from time 1 to time 2, the big ideas are the most important thing. Whenever you integrate velocity, it's on the golden notes, what are you always finding? Like that integral is going to come out to be some value. That value will represent a real thing in this story. Hands up. What does it represent? It's on the golden note. What does it represent? Let's go, Amanda. Represents always the change in the amount. So the amount in this case is position. So it's going to tell me if my position is 7, if this integral comes out to be 3, raise your hands please, 2 for Amanda. If my position at time 1 is 7, and this integral turns out to have a value of 3, raise your hand if you can tell me the position at time 2. There we go. Luke. 10. No worries. You do have to keep track of which way is it going. So the integral is going to tell you between time 1 and time 2, how different is the position at time 2 versus the position at time 1. So if the integral comes out to be 3, you'll know this has to be 10. Because the integral is telling you how different those two positions are. 2 for Luke. Question? Cool. So you just got to do the integral. And if we want to use the complete theorem, we would write over here x of 2 subtract x of 1. But x of 1 is simply 7. So now we have this. Now is where I'm like, dang, why can't this be a calculator problem?
Yes.
Oh well. Questions? Hands up. Who knows the antiderivative? Come on. Think with me. Don't just watch. What is the antiderivative? If you find yourself not raising your hand, you've got to get in here and practice. Otherwise, you're just throwing away $100 because you won't pass. Maris.
It's 4t minus 2t cubed.
Nicely done. So we have 4t, subtract 6t cubed over 2, sorry, over 3, which will be 2t cubed. That needs to be evaluated from 1 to 2. 2 points for merit.
There, you got 2 points.
So that's going to be 4 times 2, subtract 2 times 2 cubed, minus big parenthesis now, 4 times 1 minus 2 times 1 cubed. And all of that must equal the position at time 2 subtract 7. Please.
Aren't you finding x of 2 and then x of 1? Like right there?
Good question. Not quite. Because this, what I'm really finding is, like this isn't quite x of 2. And this isn't x of 1. Like we know x of 1 is 7. And this isn't 7. The reason they don't quite match up is because there's a constant involved in finding x of t. And we are not taking the time to discover the constant. The math's kind of just subtracting it away. I don't know if that answers your question.
So
So the constant would be something like 5.
There will be a constant, but there'd be a constant here, and there'd be a plus c here as well.
So the equation that we find by anti-differentiating v of t is not x of t.
It's close. It's x of t, except we aren't taking the time to find the constant.
So it's x of t minus c.
Correct.
Oh.
And we could do it that way. I prefer to use the fundamental theorem method because this problem can be done 2 different ways, but some problems can't. But the fundamental theorem is the constant, like it's the way that always works. So I just show the fundamental theorem method. So that's 8, subtract, don't let me mess up. 2 cubed is 8, times 2 is 16.
Oh, you just messed up.
Now he's got me afraid. So that's negative 8, minus 4 is negative 12, plus 2 is negative 10. Move the 7 over. Question? Did I answer your question, Mayor, about the C thing?
Yeah, well, I
I've
just
got 5.
thought that x of 1